Hi, it's Simon at National Refrigerants, and here's a brief post-Brexit update on what's happening in the world of refrigerants. Throughout our history, almost everything that we create to make our lives easier in some way or another has a detrimental effect somewhere else, and cooling has been no different. For almost 200 years now, we've been using machines to help keep things cool and make our lives easier, but this has come at a cost. The earlier CFCs were slowly destroying our ozone layer, so we simply don't use them anymore. One of the next earliest refrigerants, and still widely used today, is ammonia, but this is a toxic refrigerant and has caused a number of deaths. Hydrocarbons like R290 and R600A, basically propane and butane, for years now have been used in domestic and small fridges because of their small charge sizes. And although they have a good safety record, there too have also been deaths caused by refrigerators leaking in confined spaces. So, as a refrigerant, hydrocarbons do have limitations. Lastly, there are the HFCs, which are greenhouse gases, and while they are non-toxic, non-ozone depleting and non-flammable, they do contribute towards global warming, and as such they have to be controlled, which is why we have the F-gas legislation. Right, let's put it to bed. The UK leaving Europe will have no immediate impact on the current rules regarding F-gas. Irrespective of any differences we may have, the UK, along with most of the world's countries and their leaders, all agree that climate change is happening and that we must all play our part in controlling the negative impact that we are all contributing towards. This means that the European F-gas legislation has more or less been written into UK law, with only a few minor differences. We now have our own UK GB refrigerant quota, though this does mean we are no longer able to use European quoted refrigerant in the UK. As we progress towards 2030, we will continue to follow the original targets, but should we need to, we will have the ability to change our legislation, though that is highly unlikely. To show things in some sort of perspective, if you used a P to represent CO2 with a GWP of just 1, then a small walnut would be R1234YF. A tennis ball would be the new R404A long-term replacement 455A. R134A would look like an ostrich egg, and 404A would be about the size of a football. Then a really bad one like 508 would be the size of a beach ball, and your everyday 410A would look like the size of a 2-litre bottle of your favourite pop. To stick around as a long-term sustainable replacement, it can't be any bigger than the size of a regular coffee, but would be much better if smaller than the size of the tennis ball. Prior to 2015, it was a free-for-all, and all throughout Europe you could sell, make and use as much HFC refrigerants as you liked. Since then, we have entered into a quoting system that aims to reduce the higher GWP refrigerants and get them replaced with more environmentally friendly options. So it all started in 2015 when the refrigerant pot was filled and divided up between the number of incumbents. So as not to penalise any late arrivals, a new entrance pot was created and new companies were allowed to apply for a slice of that pot. The new entrance pot consisted of 11% of the incumbents pot, so it's useful to note that the 2015 100% pot was never actually 100%, it was 89%. So in 2016 we saw the first reduction, down to 93% of the original pot. In 2017 there was no reduction, but we did see the introduction of a 2-year deferred pre-charged equipment requisite. So from 2017, all non-European equipment manufacturers that import pre-charged equipment have to buy quota to cover the refrigerant in that equipment. No one knows the true impact of the extra demand on that quota, but it has been estimated to be approximately 10 to 15% of Europe's total demand. In 2018, we saw the first big cut when prices went crazy until things settled down a little bit. Now in 2021, we have just welcomed in the next cut, equivalent to 18% of the original pot. But if you compare that to the 2020 pot, it's actually looking much worse and is just under 30% of the 2020 total. R134A now has 3 established lower GWP replacements like R1234ZE, which is being used in a lot of data room chillers and seems to be working well, though it does have the problem of being an A2L. R513A, which is a blend of 134A and R1234YF, and while being non-flammable, its GWP is still a little too high at 573. And then you have R1234YF, which has now been fully accepted and adopted by the automotive industry as a long-term replacement for 134A in automotive air conditioning. R404A now has established lower GWP replacements like R448A, 449A, along with R452A, which is used for hermetically sealed systems and refrigerated transport. Unfortunately, none of these options are long-term solutions. For 410A, this is still quite limited. R32 is now well established in AC splits, but again, it is only an interim solution and has flammability issues. More recently, a new blend from RS is being considered as a lower GWP non-flammable interim solution with just half the GWP of R410A, so could help in the interim if it works well. But being a 6-part blend of R32, R125, R134A, R1234ZE, R227EA and CO2, it makes it a very complicated blend, and it's still too early to tell if this will cause any problems. Some of the new kids on the block that are attempting to gain traction are R515B, a long-term low GWP replacement for R134A, actually non-flammable using ZE and R227EA. And then there are all the 4048 alternatives that are long-term sustainable, but as you will notice, they are all A2L. So as it stands, the industry and manufacturers are just going to have to find a way around that. This leaves R410A with 454B, the lowest GWP contender at 466. But is it low enough? And it's flammable. I've included 470A, otherwise known as RS53, which is a relatively new 410A alternative. And I included it because although at 909 it is not below the 300 threshold, it is non-flammable and is being marketed as a non-flammable retrofit alternative to 410A. So it could at least be a stepping stone to keeping VRF running for a little while longer. And finally, we have examples of the interim lower GWP alternatives along with possible long-term solutions by application. For scroll chillers, large and very large centrifugal chillers, dedicated heat pumps and air conditioning systems. But one thing is clear, we still have no clear solution to a greener long-term refrigerant future. But we are closer than ever before. Thank you, and if you would like to know more, please visit nationalref.com or call us on 01455 630 790.